So in this video, we are going to continue solving problems from exercise 13.6, which belongs to chapter number 13, surface areas and volumes. So here we are going to look at problem number 3. Let me zoom in, get into this focus. Okay, so let's see what problem number 3 says. It reads, a soft drink is available in two packs. Okay, pack number 1, a tin can with a rectangular base of length 5 centimeter. So this is 5 centimeter, width 4 centimeter. So width is 4 centimeter and height is 15 centimeter. Height is 15 centimeter. So quickly let us note down whatever is being told to us. So I'm just going to write here L is equal to 5 centimeter. Okay, this is our breadth. So breadth is equal to 4 centimeter and this is our height. So height is equal to 15 centimeter. These are the dimensions of a tin can with a rectangular base. Okay, so you should understand that this they are talking about a cuboid, a solid figure cuboid. So this is the first pack, and the second pack is a plastic cylinder. So this is a plastic cylinder with circular base of diameter 7 centimeter and height 10 centimeter. So base is 7 centimeter. So let's come here a bit. Okay, so base is 7 centimeter. So I'm just going to draw. It's a base diameter. Okay, not a radius. So I'm just going to say, okay, diameter is equal to, yes, 7 centimeter, and the height, let us draw the height. So let's say this is the center, this is the center, height is this line which connects the center. Now height is 10 centimeter. So again under arrow, and height is equal to 10 centimeter. Okay, so we have these two solid figures, figure number 1 which is a cuboid and with these dimensions L, B, H, and then figure number 2 is cylinder with these dimensions diameter and the height, and we have to find out which container has greater capacity and by how much. So basically indirectly we have to find out the volumes of these two figures. Once we find out the volumes of these two figures, we can tell which of them has a greater volume and by how much. Okay, quite a simple and straightforward problem. So let's start with cuboid. Let me try to zoom in. Okay, so we all know the formula to find the volume of cuboids. So I'm just going to write here volume of cuboid. What is the volume of cuboid? Or rather, what is the volume of any solid three-dimensional figure? It is the area of the base, okay, so length into breadth into the height. That's a generic formula for any solid three-dimensional figure. So I'm just going to write the area of the base. So it is going to be length into breadth because it's a rectangle, and that area of the base multiplied by the height. So that is equal to, this is 5 into 4 into 15. Okay. Now that is equal to 5 into 4 is 20, 20 into 15, and that is equal to 15 into 2 is 30 and 0 centimeter cube. Okay. Once again, the dimensions are very important. Sorry, the unit is very important, centimeter cube. So I'm just going to box it. This becomes the volume of cuboid of this rectangular tin can. Now we come to this plastic cylinder. Let's bring it into the focus. Yes. So the plastic cylinder. Now diameter is given to be 7 centimeter. So radius will be half of 7, which is 3.5. So let's, okay, cool. So let's try to calculate the volume of this. We are going to write here. So volume of cylinder. What is the formula to calculate the volume of cylinder? That is equal to 1 by 3 pi r square h. Okay, 1 by 3 pi r square h. Oh no, sorry. Volume of cylinder is pi r square h. I am so sorry, not 1 by 3. Okay, so pi r square is the area of the base and multiplied by height. That becomes the volume of the cylinder. I got confused. 1 by 3 pi r square h is the volume of a cone. So that's not what we're talking about. Okay, so volume of the base is circle, which is pi r square and into h. So that is equal to pi. Let's keep pi as it is. Radius will be 7 by 2. Okay, the whole square, and h is equal to 10. So that is going to be 10. So that is equal to pi. I can write as 22 by 7 into 7 by 2. I can write 2 times because it's a square into 10. Okay, this becomes the volume of the cylinder. Now this 7 and this 7 will cancel each out. This 2 will make this 11 and this 2 will make this 5. Okay, so what remains eventually is 11 into 7 into 5. That is equal to 11 into 35. Okay, that is equal to 11 into 5 is 55. 5 gone carry. 11 into 3 is 33 and 5. 33 and 5 is 38. So 38 5 centimeter cube. This becomes the volume of the, let me use a highlighter. This becomes the volume of the cylinder, pi r square h. Now, let's compare. Yes, so very clearly we have two volumes, 300 centimeter cube and 385 centimeter cube. So the volume of the cylinder is greater. Okay, that's what the question is asking. Let's come to the question. Which container has greater capacity and by how much? So the greater capacity is clearly cylinder, 385 centimeter cube. By how much? By 85 centimeter cube difference. So just subtract this from this. That's it. Quite a simple and straightforward problem. We are given standard two three-dimensional figures, and we just have to calculate their volumes. That's all.